Thank you very much. Good afternoon, everybody. Thank you very much for the opportunity to present my presentation online. My name is Shqipe Buzuku. I am a doctoral student from Lappeenranta University of Technology, Finland. Today, I'm going to talk about a case study in the application of design structure matrix for improvement of policy formulation in complex industrial wastewater treatment. This type of work is a bit different. I consider that it's a different in terms of using design modeling methods compared to the other projects that has been DSM used so far. For this agenda of this work, we briefly introduce policy formulation in a complex problem. The few words about policy formulation and what is the policy design indeed. What are the aim, what is aim, objectives, and research questions? Then we move forward with the methodology. In this part, we proposed an approach by proposing and incorporating different modeling methods, as are like in this case morphological analysis and design structure matrix. We explain via case study how we can policy measures extract from the, morphological analysis, and all of this data with all of this data, we try to we build the DSM in order to analyze and visualize these measures. Then DSM as an advanced tool helps to organize, reorganize, screen, and improve these policy measures. We further go with some results and discussions, and we end up with the conclusions and future work. So in this policy formulation is considered as a complex, complex problems, because indeed it is a complex decision-making problems, because it includes a large number of stakeholders and many possible measures. In this case, like complex systems is divided into many separate manageable subsystems, which can be solved like individually. Whether we have, we try to simplify and to tackle these complex problems first with morphological analysis. We have different n parameters, and under of this each parameters we have the number of the alternatives, which can show us a large number of other from one big problem we have many sub problems under this stage. So the research idea is how to interlink policy science with complex engineering systems. So in terms of design and formulating effective and acceptable policy, it's still a very difficult task for the decision makers and stakeholders. The policy formulation and policy design, we have briefly a conceptual framework for this stage, that we start with a feasibility study by gathering a lot of data and information related to our project. The project is to for building, construction, operating, and maintenance a wastewater treatment plant. And the case study is in Brazil. So this is a not surprise for having this case study, because I will explain later how are these data gathered and implemented through of these design modeling methods. In order to, for example, in this case, In the policy formulation, we have a feasibility study when we gather a lot of information, and in problem definition, we define specifically goals and objectives. But as a researchers in policy design, we have to really to select the method, which method fits the best our goals and objectives in order to reach the environmental goals and targets. In selecting the methods, we thought the best tools in this case is morphological analysis, but not only that, having in mind their limitations, by continuing with the design structure matrix, which can help a lot in improving this policy in this context. But morphological analysis, first it starts with the problem formulation, and we design the parameters and values, and all of these parameters and values are evaluated in one cross-consistency assessment. The main aim of this work is to propose an approach for managing complexity of environmental policy formulation, particularly in industrial wastewater management. So the specific objectives of this work, we consider that is to better understand the problem structure and the composition into sub-problems. We have to improve analysis and optimization of the process of environmental policy formulation, and we decrease the required time for problem analysis. Then research question was very simple: how to apply DSM as modeling and analysis approach in this particular project that we are with the intention to increase effective and acceptable formulation. And what are the assumptions and constraints to be made in policy formulation in this domain using design structure matrix? So far we have we proposed the methodology we proposed the methodology by going through three main steps. The first steps consist in policy formulation, when we develop a large number of policy measures related to wastewater treatment plant. These measures, we need to specify what is the relationship among of these measures, and always having into taking into considerations what are the criteria and that needs to meet the sustainability development. And this we do the categorization of these measures based on the sustainability criteria. Design modeling methods we used, as we mentioned, like morphological analysis, that helps to structure the problem, and design structure to formulate the problem. But in this case, design structure matrix helps us to improve further these measures. And it will be a future, like this business process modeling and notation will be used with the order to show in details how a policy measures will be described in the detailed steps by decision makers in terms of implementation. So the last stage is process of evaluation and validation, when we select the policies for implementation, and there are a lot of analysis and discussions about the findings, which would be better improved with the participation of stakeholders and feedbacks in the different workshops. And in this case, we proposed our new approach first by developing a morphological matrix, and then the second stage is to develop a design structure matrix in order to deal with all these policies that are developed and formulated for wastewater treatment plant. So here I can say a very few words about this is a decision supporting tool for this wastewater treatment plant is applied to an integrated pulp and paper mill in the Mato Grosso do Sul state in Brazil. We consider that decision making, it can be very complex in this case because it's because of the capital and operational costs involved, but not only for that, but because of the activity that it has occurs on one federal river forming a border area between the two states of Mato Grosso do Sul and Sao Paulo. So we explained this proposed approach by going through of these different stages. So first we have morphological analysis. We have different parameters. We have different parameters, and under of these parameters, we develop a list, or not list, but we develop a number of alternatives. So this is called like this method is used in 1969, is invented from Switsky in 1969, and later there has been a lot of computers that has been developed developed this method. So in our case, we have this case study by first by designing the parameters, for example, which are the main parameters in the pulp and paper mill industry. First parameter, implement legislation. We consider that this sustainability criteria has to deal with legal, financial, social, environmental, and technical aspects. So in the legal aspects, for example, we have to deal first with the implement legislation. And the technical aspects is like, what is the water and effluent quality? Like, what are the really technical aspects in the water quality of the effluent of the plant? In financial aspects, we have to deal with what are the measures that need to take or to invest in, for example, installing cooling towers, to invest in the wastewater treatment plant. So moving forward with the capacity building and monitoring in the environmental aspects. So I have to try to move. In this case, to see how it works, morphological analysis, we have been assessing via this matrix, which is called cross consistency assessment. And then each parameter under it, in order to see how it works, the morphological matrix and what is the morphological field. So we have been constructing this cross consistency assessment. And here we give an detailed algorithm how we build this morphological matrix and how we have been evaluating these values. So first we input the parameters and values, and then in this stage we have cross consistency assessment. We check all combinations in this matrix with another combinations, and we call this like from number 3, 2, and 1, which in this case, in this case, with the number 3, we denote a combination which is the good fits or the optimal pair in terms of combination. So with the number 2, it indicates the possible combinations, but the number 1, it tells that it's not a good combination or it's not consistent. So the idea is that in total, we have 2,700 formal configurations, but the idea is how we can reduce these combinations, how we can reduce this matrix in order to be the reduced set of this policy should be a subject in the contact with the stakeholders to discuss further for their implementations. So we have a small box here in describing, for example, for number 3, 2, and 1, we evaluate this, and we have totally, with the number 2, we have 135 possible combinations, rather than with the number 1, we have the number 1 is omitted. It's reduced from the matrix, so we can see from this part. So when we have this inconsistency of these combinations that can give us a 0 value, we reduce this, and the idea is to keep only the best combinations that has the number 3s. So this number 1, it gives the inconsistency combinations, and then it's called we have the 0 fields. So here is totally a list of satisfactory policy measures when we have in terms of combinations that are the best combinations, like for the just selected with the number 3s. And here are the results. How much is the percentage of these combinations, for example, just with the number 3, which are the optimal combinations? And here are so far results from first parameter to the last parameter, always have combining with their values. So all of these combinations we store, and we consider that these data are not enough to we consider that these data are not enough to further do something with our project. These policy measures, we cannot stay only in that stage, because we consider that this morphological analysis has some limitations. It has some limitations in treating the interdependencies. We have the number of the combinations, but still we consider that is a static analysis modeling of the values. So, and there is a lack of support of prioritizing which alternative we have to take from all of this, which is the best in this case. So then there is also lack in screening and selecting the most satisfactory one. Like we have generally all, but still it's a large number of all these measures to handle it, to deal with them later. So lack in improving as well. What we think that is the very optimal and the very optimal method in this case to use, we thought that is design structure matrix fits the best this gap, to see, in order to see what is the interdependencies of these measures once we select the best one, how they can conflict, like what is their because they conflict each other. So what is the best policy measures? What is the time of implementation? What is the risk of this policy? And what is the cost of this policy in terms of implementation? So we have here a typical wastewater treatment plant, how it looks like for a pulp and paper mill, like having the different units here, and how also all these units, not only in the technical part, but also in environmental aspects, should be we have to take into consideration the environmental aspects. What is the effluent of this from this plant in the environment? So we have this data, and we have worked very closely, like intensive collaboration with the a large engineering and consulting and engineering company, Peru, that has different case studies in pulp and paper mill industry. And by developing many meetings, seminars, and interviews face-to-face, we have identified some policy measures, but in this case about wastewater just for pulp and paper mill industry. So we identified as well the list of stakeholders. What are the stakeholders? What is their impact? Like we consider their impact in the decision-making process. But in this case, we have to listen the voice of stakeholders, whether they approve and they agree in the decision-making of this policy or not. So once we have selected the best policy measure, just as an example here, once we have selected the best policy measure, we have to build a design structure matrix. So we have different sets of policy measures which could come with morphological analysis. Further, build the design structure matrix to see what is their connection of this policy, how we can deal with this, and what is their what is the situation with this policy in design structure matrix. So for this reason, we have still like 25 policy measures, and in this case we have we try to in the collaboration and in the different workshops and meetings with project managers and planners and designers from the Peru company, we discussed with them whether this policy could be we can create some clusters in order to create some packages later to go further for their implementations. And in this case, we have seen that these clusters, we have just roughly identified two blocks in this design structure matrix, but we have to deal with this biggest couple blocks, but when we still consider that it's still complex, and we have to see what is there to minimize the risk and how to minimize the time and risk, and in terms of the implementation. So we have to, once we see this policy, we have so far seen as a result that these requirements, which it belongs to the legislation, implement legislation, then it's in the row 10, this environmental requirements in Brazilian environmental law show the potential contradiction with the column 20 and 21. And these columns are like, they show potential contradiction because in the column 20, it says that we have to create a water management system for clean used processed water. And the next is like, what is the temperature in mixing zone? And 24 and 25 are like, what are the, like all organic compounds and nutrients should be measured and meets the environmental Brazilian law criteria, as well as physical and chemical parameters which are relevant to this point. So in this case, we have seen that this is still in potential contradiction, and we have to repeat our process in this DSM matrix to see to improve in this case the process of this policy, because we know, as we know, that this environmental law has the major criteria of the implementing some policy we have from generation from environment. I mean, it comes from the legislation. So
Buzuku, please,
yes?
Could you conclude, because we have the schedule?
Yes, and I have just some results and discussion. We have to come to these results that we have seen that there are only 2 coupled blocks that are developed by tiering. So I didn't talk about much for tiering and this part, as all the community of the DSM is there and they know better than me, but it's still like we want to know what is the sequence and of process flow of particular policy. And then out of 25 components, which are policy measures in this case, we have only found 17 components in the 2 coupled blocks. So in the discussion with experts and managers, the focus was directed to this policy of environmental in Brazilian law for reorganizing and improving the process. So next, we have to finalize, the final optimized task sequence was discussed with the managers and policy planners to identify and improve the issue of implementation. So, but in the real world, we say that morphological analysis and design structure matrix, both has shown very successful approach, are proved as very successful approach for solving complex problems, and in this case, particularly in environmental management systems. So we have to summarize this like we have as a summary, we say that comprehensive definition of environmental policy formulation in complex industrial wastewater treatment. We have relative measures of sustainability policy for this modern organization management, and then application of modeling methods as are morphological analysis and design structure matrix in policy formulation. So we have we see that DSM techniques allows us for reorganizing and improving the policy formulation process in very early stage of the conceptual design in the context of building, construction, and operation of the wastewater treatment plant. Then we conclude that DSM also highlights very critical dependencies. So with the DSM permits deeper insights into analysis and environmental policy by considering simultaneously many attributes. And also DSM has to improve decision-making by engineers, planners, and designers, thanks to facilitation of communication with them across all these domains. But in future work, we still consider that we have to promote and the use of modeling tools in the formulation of environmental policies. And another approach could be considered the business process modeling and notation to formalize the description and integration of the processes. So here is just to acknowledge some Finnish Cultural Foundation that was financed from this with their grant, and here are short information of mine. Thank you so much.